This is going to be the second video about properties of exponents. And there's a few more properties I'd like to go into in this one. The first one is something like this. So let's say you've got x squared y to the third. You've got this expression. And you're raising the whole expression to the fourth power. Well, remember when we had something like just y to the third raised to the fourth power, we multiplied the 3 times the 4. In other words, we multiplied the exponent inside the parentheses by the exponent or power outside the parentheses. When we have more than one part to this expression inside the parentheses, in other words, more than one base, we're going to use that same rule and we're going to apply it to each of the bases and exponents. So in other words, this is just going to become x squared to the fourth, or x to the eighth, and y cubed to the fourth, or y to the 12th. If we wanted to write this out in general terms, we could say, I guess, that if we have x to the m and y to the n, and we want to raise all this to the p power, then we would have x to the mp, in other words, m multiplied by the p, times y to the n multiplied by the p. Oops, p. But in general, the main thing to remember is you're more or less distributing this exponent. You're distributing it to each of the exponents inside the parentheses. One place to be careful of that I see some mistakes sometimes is, let's say you've got something like 3x y to the third, and you're told to square this. Well, remember, if you don't see an exponent, you could just write a 1 in as the exponent. This will remind you that you've got to square the 3 and the x as well as the y to the third. So this is going to give you 3 to the 1 times 2, or 3 squared, x to the 1 times 2, or x squared, and y to the third squared, or 3 times 2, y to the sixth. And then you probably want to actually do the squaring here. 3 squared is 9. So you're going to get 9x squared y to the sixth. Another situation where we have parentheses is where we have a division inside them. So for instance, if we have x to the third over y squared, okay, and remember, we can't simplify this because the bases are different. But if we have this expression and we want to raise this whole thing, let's say again to the fourth power, then once again we're going to distribute this 4, this outside power, to each of the exponents inside the parentheses. Okay? So this is going to give us x to the 3 times 4. I'll do this in 2 steps. Over y to the 2 times 4. And then I'm just going to multiply these out. I'll get x to the 12th over y to the 8th. So just like with the case of multiplication, if we have a fraction, if we have division, we still take this outside exponent and distribute it to each of the exponents inside the parentheses. If you don't see an exponent, so in other words, if we had 3x squared over 4y to the third, and we're told to square that, remember that you basically still have an exponent for the 3 and the 4, so we're going to have 3 squared is 9, x squared to the second power will be x to the fourth, 4 squared is going to be 4 times 4, or 16, and then y to the third squared. 3 times 2 is 6, so I'll get y to the 6th. Okay? The last rule I want to talk about is what you do with a negative exponent. And I'll do a separate video in general explaining what negative exponents really are. But if you're given something like this, let's say you're given x to the negative 3. If you have a negative exponent and it's in the numerator of a fraction, so let's actually write this as a fraction. Remember, anything that doesn't look like a fraction, you can make a fraction by putting your little fraction line and a 1 in the denominator. Anytime we have a negative exponent in a numerator, we can take the base, put the base in the denominator, change the negative exponent to a positive exponent, and if there's nothing else in the numerator, just put a 1 there. If the negative exponent was in the denominator, so if we had 1 over x to the negative 2, we would just do the opposite. We would take this denominator, move it up into the numerator, change the exponent to a positive. So we're going to have x squared over 1, but we don't have to write the over 1. So this just becomes x squared. Okay? I'm going to just take 1 second more, actually probably a minute more, to caution you about something. So if you have more than one term, more than one variable, let's say we have x to the negative 2, y to the 3rd, and we want to get rid of that negative 2, we'll think of this whole thing as a fraction. But the only part that has a negative exponent is the x, so the only part we're going to move is going to be the x and its exponent. In other words, this y to the 3rd stays right where it is. Y to the 3rd over x squared. Okay? There'll be plenty of chance to practice this. I just wanted to go over the general rule for you, which basically says if you've got a variable with a negative exponent, you move the variable, the base, or it could just be a number, like a 3. You move whatever the base is and its exponent to the other part of the fraction. You move it from the denominator to the numerator or the numerator to the denominator and change its sign. So this is going to become 1 over x to the n. And if we had 1 over x to the negative n, that would become x to the n. You could write over 1, but you don't have to put that part in. Okay, so that's it for the basic rules. Take care. I'll see you next time.